me to do any one of 2 to 18, I won't go through them all, I'll just ask you. So if anyone needs one done, ask me now. Question 8, yeah. Okay, so question 8. Question 8, the graph of the function y equals a e to the power of x plus b, is shown. Find the values of a and b in terms of e. Right, okay, so what we need is 2 points off the graph. Okay, so we have 114, right, and we know all those to the power of graphs, right? Okay, well, no, that mightn't be naught, sure it might be. Is that naught it goes through? Yeah, it goes through naught, and it goes through naught, so I do have 2 points. Is that alright? So it goes through 114 and naught. Okay, so sorry, I'm fogged up here, can't see a thing. Right, so everywhere I see an x, put in a 1, everywhere I see a y, put in a 14. See how you get on. So so y is 14 equals a times e to the power of 1 plus b. Can't go any further with that. Right, over here, do it again. Everywhere I see an x, put in a 0. Everywhere I see a y, put in a 0. So I'll get 0 equals a times e to the power of 0 plus b. So that means a plus b equals 0, because e to the power of 0 is 1, isn't it? Right, is that okay? And then rearrange, right, okay, so I might rearrange here. So I get b is equal to minus a. B is equal to minus a. Very good. Over here, come back here, everywhere I see a b, put in a minus a, so it's ae minus a. Yeah? Okay, so then take out an a, that's e minus 1 equals 14. So that's a is equal to 14 all over e minus 1. So that's a in terms of e. And then b is equal to minus a, so b is equal to minus that, minus 14 all over e minus 1. Is that right? Okay. Good. So they're both in terms of e. Right, that was number 8. Anything else for me? Anyone need any other ones? 10, 12, 14, 16, 18. We're okay? We're all good? Right, okay. So what I wanted to do now was the next one, which is related graphs. Okay, girls, just on this is the last section in this chapter. Okay, I'll do a few revision questions tomorrow and you'll do a test on Friday. Okay, we have to pick up the pace a bit. I'm about 3 weeks behind, if not 4. Okay, so I need to catch up the time. Okay, I'm going too slow. I know you're probably looking at me going, you're flying it, but I'm going too slow. Right, so test on Friday on this chapter, is that alright? Okay, and we start differentiation next Monday. Right, so related graphs. Right, this is like what happens when you multiply by a constant, when you add a constant, right, when you change the sign of a graph, etc. Right, okay, so related graphs is, the first thing is, if you have your graph f of x, so your original graph is f of x, what if you add a constant? So plus or minus a. So you add 2 or you minus 2. Okay, so all it is, right, if I just draw y equals x squared, right, x squared goes through naught. Right, if I draw y equals x squared plus 2, everything moves up by 2 units. So everything goes up to there. So it's the exact same graph, except it's moved up by 2 units. Right, so that goes through 2. What about this one? What would this one? The one that goes through 4, what would that be? What would that graph be? It's gone through 4 there, so it would be y equals, the original was x squared, so we've moved it up 4 units, so it's now x squared plus 4. Yeah, anyone out there? Right, okay, what if I moved it down? So this is the original, y equals x squared. What if I went down 2? If I went down to minus 2, what would that be? Y equals x squared minus 2, right? Okay. So, and that holds true for any shape, okay? So if I have a line, right, a line that goes through 1 and minus 1, right, okay? So if I, what is that line? That line is got a slope of, oh, I should have picked one that I know the equation of it. Just give me a sec when I get the equation of that line. Y equals zero, 1, minus 1, 0. Sorry, my brain isn't working. I'm just trying to figure out what the equation of this line is. Yeah, I minus 1 naught. 1 naught. So I think it's minus, no, it couldn't be minus x. I think it's x minus 1. Yeah, okay, right, so that would be the line y equals x minus 1. Right, okay. Then if I add 2 to that, right, you just move everything up by 2 units. So I'd be up there at 1, and this one would be up here at 3, but it's the exact same shape. Okay, so that would be y is equal to x minus 1 plus 2, which is x plus 1. Is that right? Okay, if I moved it down by 2, right, that would go down to minus 3, and that will go down to minus 2, and there we go. So it's the exact same shape, right? Okay, it just moved up and down. So plus or minus a, if it's plus a, it moves it up. If it's minus a, it moves it down. Are we okay with that? I have a PowerPoint presentation that I can show you in a minute, and you'll see it more clearly, okay? But I just want you to have something to write in your notes, okay? Is that all right? Are we good with that? Right, okay. So that's number 1 graph. Yeah.
What did you say the equations were for the other 2 lines on the straight line graph?
The first equation was y equals x minus 1, and the top line is y is equal to x minus 1 plus 2, right? And this one is y is equal to x minus 1 minus 2. So I moved it up 2 and I moved it down 2. Is that okay? Yeah. Now you could simplify that to minus 3, but I want to make it obvious I moved it down 2. Right? Okay. So number 2 is y equals f of x plus or minus a. So this one I'm changing the y coordinate, okay? So I'm moving y was here, and now I'm moving y up and down, right? So I'm changing the y coordinate in number 1, okay? So in this one here, I'm changing the y coordinate because I knew y, so I'm adding on plus a constant or minus a constant to y. So I'm changing the y coordinates, okay? In number 2, I'm changing the f coordinates, right? Okay, so our x coordinates, right? Okay, so if I had, I'll start with y equals x squared again. Right, if I have the line, the curve even, y equals x squared. Okay, so that's one function. Right, if I then draw the function y equals x plus 2 to be squared, so, right, y is equal to x plus 2 to be squared. So it moves the graph along the x-axis, right, but it moves the x-coordinate, it moves it in the opposite direction. So x plus 2 to be squared will move it back to minus 2. And this one up here is x minus 2 to be squared, right, we'll move it up 2. Okay, so when you change the y, it did exactly what it said in the tin. As in, if it was a plus, it moved it up. If it was a minus, it moved it down. When you change the x coordinate, girls, it does the opposite. So if you add 2 to the x coordinate, it'll move it over minus 2. It'll move it 2 steps over to the left, right? And if you minus 2 it, it'll move it 2 steps to the right. It'll move it 2 in the positive direction. So the a's are different. So y is equal to f of x plus a results in translating the graph. Translation means the shape doesn't change, okay? So when you translate, the shape doesn't change. So in translating the graph parallel to the x-axis, by minus a units. So if you change the x by a plus, you'll actually move it in the negative direction, right? And if you change the x with a minus, you actually move it in the positive direction, okay? Results in translating the graph parallel to the x-axis by plus a units. Okay, so if you change the y, it does what it says in the tin, as in if you add to the y, it goes up, if you minus from the y, it goes down. The x's are the opposite. If you add to the x, it goes in the negative direction, and if you minus from the x, it goes in the positive direction. Is that okay? Right. The next type of translation that you need to do, or it's not a translation anymore. Right. Can I take that away? Are we good? Going, gone. Right, number 3 is, what if you change the sign of the function? So we drew, so if you drew, sorry, again I'll just go with y equals x squared. So that's what the graph y equals x squared is. Right, if I was to draw y equals minus x squared, right, so y equals minus x squared, it reflects it in the x-axis, right? So it's the exact same shape, but now it's upside down, right? So it's like axial symmetry in the x-axis, right? Graph of minus fx is a reflection in the x-axis. So you take the original graph and it's like you do fold it along the x-axis and you get so the graph of minus f of x is a reflection in the x-axis. Okay, we're good with that. That's the third type of reflection, and the fourth one. And as I say, I'm going to show you a PowerPoint in a minute where all these are done, and you'll be able to see it more clearly. But this is just so you have something for your notes. Okay, and the last type is, right, what if you multiply a function by a constant? So a is a constant times f of x. Okay, so if we have, I go with y equals x squared again. Right, this one you actually change the shape of the graph, okay, but it's just twice as steep. So it goes through the same points, but it's just, or the same turning point, but it's twice as steep. Right, y equals 3x squared would be 3 times as steep. Okay, so y equals 3x squared would be in there in the middle, or would be tighter again, steeper again. Okay, so if you just multiply by a constant, you make it get bigger faster. Okay, so it gets bigger faster. So this one was kind of slow enough to get big, but then this was twice as fast, 3 times as fast, etc. Right, okay. So multiplying by a constant by a constant will not change where it cuts the x-axis. Will not change where the graph cuts the x-axis. So it will stretch the graph, okay? So that's what is called stretching the graph. So it's the same shape, but it's like they pulled it tighter, right? Okay? When this is down, I will show you the PowerPoint, okay?